Welcome, I'm Bill Wake. We're here working on a kaleidoscope, and the last couple days we've been tangled up in boundaries, and I think we're so close to having it right now, but it's still not quite right. All right, let's take a look here. So this is our current running one, and what you notice, the circle around it is staying pretty good, and there's a little bend. So right there at that spot's a little bend. I think there's a couple more. Yeah, because we're doing, I was going to say we're doing 3 repeats, but we're doing, it looks like 1, 2, 3, 4, 5, 10. Okay. Oh, so the 3 repeats are coming from our 3 sine waves that try and read the whole thing. So there's another one that's just a little, I assume what's happening is the piece of pie is just losing just a little tiny bit too high, and it's losing it. Yeah, we said it might have to do with the +5. So image still cuts off around the edges. I want to fix that today. I guess, if this were a commercial project, I might be, look for a shortcut and just try and do it. But I think we want to get it right. Now, right is, I don't necessarily have to have the whole picture or any of that. And it occurred to me last night, there is a way to get inside an image. So the problem we have is, at least right now, we got it in a couple places. I put some extra buffers on around the image. So for the X, we're trying to go from the far left to the far right. Well, we're trying to go from the far left to halfway over, trusting that will never push us off to the side. We'll have at least 3 mirrored reflections. Maybe reflections is better than mirrored. But this 5 sticks out as being a little funny, and it guards us on the left side, but then on the right side we're +5, so we're a little further over. And then same thing on Y, we have this, and whether that's quite right or not, they look funny. So what I'm going to do, let's take these offsets out and deal with what we find, make sure we understand what we're seeing. So I'm going to take them off the X first, because I think that one's the closest to right. And we'll run this, and then we set up an experimental tab. So I mentioned Mike Hill's phrase of a making app and a shipping app, and we're definitely in the making app. I could do some fancy work and turn this tab off sometimes, but I'm not going to. All right, so you can just barely see that red outline of the triangle there. I don't know if I can stroke it with a thicker line, but as I rotate, we want to see if we ever hit the right edge of the image. Okay, so I'm going over to the left. Now, right at that moment, I can't swear that it's not a hair off. But vertically, right, that's never touching the top. And let's see, does the tip does not touch the bottom. So I don't think this XY thing does anything with that. Now let's see what happens here. If we're lucky, we've got those 3 bend points there and there. Okay, so I don't think it's hurting anything here. The only thing that might be a little funny is I couldn't tell if things hit the very far left edge a little too far over. So even a little bit of white space would show up somewhere. And I would think white space on the left side would show up as separation, which we have seen in some versions of this. Where the reflections, between the reflections, there'd be empty space. All right, now the Y. But I got to say, in our experiment, it looked to me like this was not touching. I mean, that's the +5. Up top is not touching. Okay. All right. So the thought is, if I take these out, I think if things were worse. All right. We'll run without them, and probably be more visible in here. Okay. I think that's a more noticeable bending in. Maybe it's not far off. But I still have to say, I think from the physics of it, right? If it's flat, that means the top of the pie got flattened. I don't see how that matters. Okay, but I do know in image in views we can do inset, and I think that's what we need to do. And I think I just give a number of pixels here. Let's put 5. Let's put 50. Okay. And image has no member inset. Oh, that's weird. Okay, I thought all views had that. Swift UI inset. Oop, that's not the right one. Inset by, maybe. Yeah, so, inset shape. This is on shapes. Oh, dear. Okay, well, the problem this is solving is if you take a shape, like our pie, and we stroked it with to draw it with an outline, the question is that stroke inside the shape or outside the shape? And by default, it's outside. And if you call inset, then you push it towards the inside. But it's a thing on shape and not the on view or image. Okay, now this one, safe area inset. Okay, I don't care about that. I mean, it has its place, but it's not what I'm worried about here. Content inset. Okay, let's say Swift UI inset on image. Well, that might be interesting. We can mask. That's not what we're looking at. Okay, well, apparently, that seems so weird that it seems useful in any view that you might want to inset it. You have padding to put stuff on the outside, but inset sidebar list. Okay, save area. Edge insets. I don't know if that would help. My thinking is if you could shrink this thing by the 5 pixels each way or 50 pixels or something like that. Yeah, is it margin? Maybe it's called margin. Yeah, padding. I don't know if you can flip the padding. There's so many modifiers. It's really, I really find it tough to get inside them all. This sides of a rectangle. Well, that might be. Yeah, doesn't sound promising. Padding. Oh, can I add negative pads? Okay, I don't know if I can tell. Image inside margin. It's a margin around the... Well, that's on hosting configuration. Well, let's see what padding with a negative number does. Excuse me. Oh, negative padding's not possible, huh? Well, it's definitely going to the very bottom of the image. Okay. I don't think that's mattering. Let's check this one again. Did I miss something? Oh, wait a minute. Oh, I think that is accepting the negative padding. I guess I only did it on the content view. I didn't do it on our experimental. Let's go back there. Excuse me. And I think 50 is way generous. I mean, it's more than we need. Oh, yeah. Okay. So with that working, and look, he's not coming anywhere near the top or the bottom. We don't get any blue. Okay. But I think, so that's means this is going to work in the sense of not having anywhere that bends. Now, notice we're not getting any blue. There's the lettuce. Tomatoes. All right, I'm almost all the way around. Okay, well, I think that helps. Gosh, I could swear somewhere I maybe saw somebody using negative padding. Let's try. I mean, I learned so much from this site. Padding. Maybe not. How to pay? That's different. Okay. I guess I could look at the ones that are pink, right? Instead of the safe area with custom content. Let's ignore safe area. That's something else. Okay, we're getting a bit away from that. What do we see here? Padding, bottom. No, I don't think that's going to matter. Okay. All right. Well, let's see. Oh, Code Rushed and crew, welcome. So we're working on a Kaleidoscope. We've had a slight problem. I'm going to take this out to demonstrate it. Okay, so we're taking a static image and we're taking a little slice of it and then reflecting it and repeating it around to get that kaleidoscope view. And what we've noticed is, well, it was a lot worse a couple days ago, but we see that there's a point where the image bends a little, and I'm not going to get it, am I? Well, I guess I'll talk about historically. We had something where you go around the circle, and then just at one point, you'd have something that looked like more like a polygon, you know, not a circle. And my theory was that our piece that grabs from the image, that the image was slid up just a little bit wrong, so that the pie that's grabbing the image overlapped some blank space around it, and that put some white space in there. I guess I can look at the center too. I don't. Yeah, you'd have the same thing if the bottom of the pie piece went too far. So I think we're just in position to solve this. Now, wait a minute. Why, if this is... Okay, well, let me show the experiment. Okay, so the pie is this red piece, and I've added margin so you can see it sliding around, but notice the farthest left point. Okay, well, that's all the way there. Oh, okay, sorry. Let's take it out here, and that should demonstrate the problem. Yeah, so negative padding to get the overlap, and I think if I do 90 degrees, yeah, there it is. Okay, so I think this is 10 if I'm counting right. You know, a 10-sided polygon, and we've got this little bit, and it's distracting when you're rotating. You're going through blip, blip, you know, blip, and then blip and blip. You know, so we're trying to get rid of that. And the experiment was puts this padding in to make sure that the underlying image capture never can get close to the borders. Now I've taken the padding out, and we have the equivalent of the problem. So if I take it, and then I think you know, 5 pixels is probably enough. We can clearly see we're inset from the image. Okay. And we've been going around and around. Oops, I'm still not an experiment. Okay. All right, so the bottom, it's not really to the bottom of that marble top or whatever that is. And the top is just a little away. And then the edge just stays a little away. So let's put the same padding over here. And I mean, that's pretty tight, but we want to make sure it avoids the problem. All right. Come on. It's just not quite enough. All right, but that tells us 50 it's gone, and 5 it's not. Let's try 10. And, you know, this has been a very empirical process to get this thing together like this. Meaning I wasn't sitting down and going like, oh, here's my test, blah, blah, blah. I did that originally, but we had so many things messed up, it just kind of hurt everything. Okay, so, oh, just the tiniest bit. Okay. Now, I don't know if I want to explain every problem we have with this, but the challenges going on, one of them is the y-coordinate, the y-axis, 0 is up at the top and maximum y is down at the bottom. So it sort of means everything you're working with feels flipped upside down. So, you know, I mean, I have enough math to know, like, you know, this goes around the center of the coordinate system and stuff like that, but when it's flipped upside down, I just don't have any intuition about which ways forward and backwards and clockwise and counterclockwise and all that stuff. And that definitely hurt us. Okay. Okay. Now, I'm happy that it seems like the polygon issue is gone with that buffering. But now I got to dig out of the hole that has us here. Okay. Well, one question is, where is 20 coming from? And I don't know. I mean, like just now, we did it empirically. So the other problem we had was, well, a couple others, but one of them was, at one point I thought I was moving the pie around the image, and actually I'm moving the image underneath the pie. So the experiment shows us that now. It's the image that's moving. So we'll accept that. That's good. But the other issue was, if we're back in here, where the image claims to be and where we get its size from on the original image was affected by adding tab views on the bottom. And so the image was no longer reflecting the whole screen. So we had to kind of make sure we just there's Geometry Reader that can tell the sizes of things. We had to restrict that to more just this Kaleidoscope view and go with that. So that also messed things up. But like why this is 20 and not 1 or 2 or 5, I don't have an explanation for what would do that. And I wish I did, and I'm not worried that we're going to have 40 pixel images or anything, but or images smaller than, where if they're at least 40, the padding is there. But I don't know why 20 and not 50 and why not 10 or whatever. Okay. But the other thing we did along the way here was we basically reworked all this 2x offset and 2y. I think I'll call that offset as well. Because with the image now, realizing the image is flipped and the size is smaller, and the dealing with the upside down coordinates and everything, it definitely made sense to rework it. Okay, and I've still got debugging stuff in here. I'm going to take that out for now. All right, and I'll run. So we have not been running tests this whole, definitely all of yesterday or at all today. Okay, there's that problematic zone. It looks okay. Okay, I mean, I like the look. Everything's good that way. All right. Let's check this in because we've been checking in these partially managed ones. So the big deal was we added negative padding around the image. So the pie doesn't reach any blank space. All right, and now the moment of truth running these tests, they're going to be almost all wrong. Okay. Wow, refactoring did not get those. Interesting. Now let's take 2x parend and replace that with 2x offset. We'll do all. And then there's insert missing argument. Okay, let's deal with that. To Y offset. Oh, maybe I did it manually. Isn't that nasty? Okay. X offset got a change that this mirrors. We started telling how many mirrors there were to to do it. Oh, wait a minute. Nobody's looking at it. Okay, well, let's take that off. Unfortunately, this is a manual refactoring. Build should tell me who's got it wrong. There is a reason for this. Okay, yeah. We didn't do anything with it, but I can understand. Okay, let's try build again. The mirrors, what that would have allowed. So, I'll run it on the. Okay, we're running here. Yeah, so notice on this edge, that's more than 5 pixels away or whatever it is. It's really relatively far away. And the reason is if this were a 90-degree one, it would touch the edge over here. And we wanted to make sure that even the 90-degree had its 5 pixel buffer, not just this. So we only take this vertical line as far as halfway across the picture, and so we'll never really quite hit this edge with 3 reflections. All right, and yeah, it never gets closer over there. Yeah. Okay. So we at one point were going to do that, or I don't think we ever quite did it, but that's why the mirrors were there. Passed in. Okay, now run these tests so they can all fail, or most of them. I don't know where that's actually running. What are you up to? It says testing. Yeah, I think I need to try some reboots or something. Maybe reboot my modem, maybe. It seems like the last couple days, my system has felt a bit sluggish and seems to really not be doing well and keeping the connection. I don't know. Well, I can't tell that this is running anywhere. Let's try that again. Yeah, well. Yeah, I don't. Let me. I don't know if I restart the simulator, maybe. This is really painful. Now, my monitor says my CPU is at 25%, so you think it would not be struggling. I mean, if it's going to be slow, okay, but it seems like there's plenty of room to do the network stuff. if I can tell what I have going here. I was struck that it did disappear something there, so I'm going to try and stop the simulator. Okay. And let's... Oh, good. Yeah, it may be something like that, but I don't know. It's I'm pretty sure I've run iPhone 15s. Maybe not since I rebooted Xcode last or something. I don't know. But this doesn't seem to be making a lot of progress either. None of these are running. Usually it would. I mean, it doesn't even show that the app is installed here, so something's definitely weird. I don't think I can get enough information to know. Well, I guess I can't stand sitting around. Let's look at what we expect our answers to be in our new approach. So I think the way we're doing it now, I think if you get an angle of 0, basically we map 0 to 2 pi, which is the distance around a circle, a unit circle. And if it's 0, we're going to put it at 0. And if it's 2 pi, we're going to put it at halfway across. So I think this answer should be 0. Okay, good. Now, this one, pi, that's halfway across. But we're only going halfway across our maximum. So this should be 25. Good. Okay. Now this one is pi over 2, so it should be half of that. It should be 12 and a half. Okay. I feel good about it. At least I can project what these values are. Now this one, negative pi, if you go to negative pi, you're at 270. So I think that should be 3/4. Oh, that one, 12 and a half. Oh, below negative. Oh, okay. What are we at? Pi minus pi. That one I'm not sure about. All right, well below negative pi wraparound. So this should be the same, right? 12 and a half. And this one, negative pi, maps to min x. Well, no, I don't think that's right. Negative pi is going around the circle on the bottom. And if you're halfway around the circle, we expect to be at 25. Yeah. Okay. Negative half pi is 3/4 around, so I expect 37 and a half. Value just above pi wraps around. Pi plus pi over 2. To pi plus pi over 2, I think that's also 37.5. Yeah. Value well above pi wraps around 6 pi. Well, that's 2 pi around 2 pi and a third 2 pi, so I think this should be 0. Oh, 50. 6 pi. Now, what was our 0? I thought 0 mapped to 0. Okay. Yeah, simulators. All right. Okay, so some of these are obviously good to me, and other ones, I guess it's not obviously good. All right, so 6 times pi. I don't know. I thought 6 times pi would be the same as 0 pi, because you should be able to subtract and get 4 pi, 2 pi. Is it 2 pi? Is it 50? Oh. That's tricky. That's really okay, because we may have this may be a true weird case. So if you want 2 pi to be the maximum, but the reality is if you hit 2 pi, you've wrapped around back to 0. And I think that's what's happening here. We are probably treating 2 pi incorrectly and mapping back to 0. So I think this test is failing because we're doing something wrong. I'm not so sure about the others. Let me run those again. They can't be as fast. So I think if I had a boundary wrong, when I was reducing the 2 pi and I reduced it down to 2 pi, that would correspond to the whole distance. But really it should be 2 pi minus some epsilon, right? I mean, you can be, if you got 2 pi, you've wrapped around, you're exactly back at 0. But if you did a less than instead of a less than or equal, then you got a problem. All right. Okay, so those are good. Values below negative pi wrap around. I guess I should fix the English there. Okay, so pi over 2, and if we take minus pi, oh, this is 3/4. Okay, minus pi over 2, I think that could be better said. Okay, minus pi takes you halfway around. Okay, yeah, minus pi takes you halfway around. Minus an extra pi over 2 takes you to the top of the circle, which is really one quarter of that circle. So if we're getting 12.5, I guess I'm okay. Yeah. So it wraps around up to here. Since all the way around is 50, halfway around is 25, and a quarter of the way around is 12.5, and that's where that 12.5 is. All right, I think these are the same, right? Yeah. Okay. And that's our x's. Yeah. Okay. Y is totally changed. X was at least something like this before. Okay. But I think this test is still going to fail. And I think that's an interesting failure. And I can bring this back in. Oh, which one's running now? Oh, I've got 2 testing. So slow. Now this one has Collide in it, so I expect this is the one that's actually running, but it's not. Okay. Well, I'll tell you what, I'm going to work on at least the to-do. Get rid of offsets, yes. did this with negative padding. So negative padding, we shrink the picture before we even ever start working with it. All right. And that's today. Okay. You're still testing. I guess we can look at the... Well, where's the test? I don't know how many copies of that I need. Oh, aren't you weird? Okay. All right. So, well, pi wraps around. It's just so... I wish I knew what it was really doing. There's no view I can get that, is there? Certainly not there. I don't know what this one is. Oh, I didn't know it gave me coverage by default. Interesting. Okay. Well, I guess that's moderately interesting too. There we go. It's running. Okay. Now this test. This is minus... Oh, what did it get? Did it actually run? What? Yeah, only 0.142 seconds. Like, I don't know what it's doing the whole rest of that time. No, that one has it now. Oh. And this is, I updated Xcode over the weekend, I think. And it does seem a little flakier. Okay, there we go. Something happened. Okay. That I expected to pass. What? That message doesn't even make sense. Is it really coming back 37.5? Okay, and then this one, 50. Okay. So, in a way, I don't think you should ever quite get to 50, because it's not going to quite reach 2 pi. So, let's look at Angle+toXY. And I'm suspecting here, okay, if the angle is less than 0, well, 0 should be allowed, right? So, if it's greater than 2 times pi, this should be a greater than or equal. So it should have subtracted and got down to 0. So I think that will make this test pass. Okay. And yeah, I can... Oh, man. Oh, it's a little faster. Okay. Well... Oh, yeah. No, it should have been 0. Yeah, because 2 pi should wrap to 0. We already proved 0 should be 0. So that is now okay. The other test, though, why is that 12.5? Okay, so this minus pi over 2, I'm going to inline this. That's the same as minus 3 pi over 2, right? Minus pi is minus 2 pi, minus 1 more is minus 3. Okay. See, I'm getting that 2 up there. That almost makes me think it's running both these guys. And they just sit there for so long. Yeah, there's something with, in this case, I'm running the one test. Okay. Well, above pi wraps around. Is that telling me it's coming back with 25? It doesn't seem... The wording is a little annoying. 12.5 is not equal to 37.5. Okay, I mean, that's the same message, so why is this one 0 is not equal to 25? So I'm getting 25? 6 times pi. Let me set a breakpoint and run this test, because I want to make sure. Oh, less than 0. Yeah. Okay, so I want to make sure that the effective angle is coming out to 0. Okay, so our working angle is 0. And this thing is a double, or a float of some sort. Yeah, double. Okay. So that already came to 0. Okay. So I guess when you're in radians, doesn't matter. So it's not greater than or equal to 2 times pi because it's 0. Is it less than 0? No, it's 0. Okay, so let's step over. Step over. Okay, so now working angle is 0. Percent should be 0. Yep. Okay. Minus 5 times size times width times percent. And then we're flipping result. I think this min x stuff, we got to watch that. All right, but I'm confused. Percent is 0, so this result should be 0. Minus 0. Is it really a minus 0 thing? And then we return minus result as plus 0. Wait a minute. That's not running my test. What? I'm in main. Something is really screwy. Let's see if we can clear all issues. Clear test results. Clear build folder. Okay. And then we'll run everything again. I don't think it will, but I think we ought to use 2.0 here just to be consistent on the types. I think if you've got a direct numeric constant and times a float or double, it will convert it for you. But we have that an awful lot. Let's oh, take this breakpoint off and continue. Okay. Oh, haha. Yeah, Xcode was confused. Okay, so now it's 0 is passing. Well, maybe X. I don't know. I don't think that came into play because the working angle was 0 coming out of radians, because radians will map 0 to plus or minus 2 pi. Yeah, I think you're right. A constant for 2 pi would be a good thing. Okay, so here. Okay, it is. Yeah, so it originally came up to that. All right, so that's fine. Well, I think we're at the point where the 2x tests passed. Let's check that in, even though, I mean, I know I'm checking in failing tests. I let us get in that position. Mostly because I just did not know what the right thing to do was, because we had so many things going on that confused me, basically. I don't know if that's a good reason or not. All right, so okay, Anastasia. Okay, and I'm going to pretend we're not worrying about 2x just yet, but let's make this constant. Yeah, maybe 2 pi is the right thing to call it, and it's 2.0 times double dot pi. Let's be kind of explicit. Okay, and then that comes here. Now, I don't think this can even happen with radians. That's a little annoying. I guess I could do self, but I don't think it's any less annoying. That constant shows up a lot. Okay. And let's make sure all those X tests passed. Those are all green. Okay. And then the other thing in here, I don't know if I care about the assertion. And this is pretty straightforward. Excuse me. We wrap the angle until it's in the range 0 to 2 pi. Turn that into a %, and then return the result. I'm going to take these out. in the assert. And then the sign is negative and negative, so that's irrelevant. And then we can just say return. Ugh. Okay. All right. Let's deal with the Y tests. And this one, I don't think this is right anymore. Minus 25. Well, one thing is we do negate things. They're all negated? Is that the only problem? Minus 25. Okay. Oh, interesting how you got there, right? This is 24.999 and this one was 25.0014. I mean, they're both valid, but some numeric thing going on. All right. I think... Okay, I think we have a couple tests that are acting different. Oh, and this one was fine. Okay, good. This case... All right, let's see what happens on Y offset. The radius... Where is that used? Oh, there. Okay. All right. Well, the radius, yeah, the minimum of the width and height, because we got to figure out minimum of width and height says the circle can be, the smaller of those two to make it a square, and when in there we'll draw a circle. All right. Then we're, okay, so the percent is, we take the sine of, well, basically it's the sine of the radians. So we get the sine, we multiply it by n. Okay, so in our case, the way we're covering a rectangle is, you could see those three sweeps up and down in the experiment view. That's this repeats. So the sine of n times x is, repeats n times as fast. Okay, so if you take the sine of that gives you a number -1 to +1. If you add 1 to it, it gives you 0 to 2, and divide by 2 gives you 0 to 1. Okay, so it's sort of a percent. Then we're taking the center. Okay, so we're starting the center at the middle of the height of our picture. The minimum Y offset, if you take the center minus the radius, that leaves room for the radius at the top. Okay, and then the max Y offset, it's size.height over 2. I'm not as sure about that one. Okay, but the result, we did the same. Okay, this was more of a debugging thing. All right. This negate of negate, the value is going to be negative, but all right. So now why this is size.height over 2. the maximum Y offset. It says to height over 2. I don't know if that's getting us the same. I mean, it looks good on our experiment page, so maybe it's okay. But all right, so for the sine function, I know sine of 0 is 0. So if we send in 0 for radians, we should get 0. But this percent thing turns that into a half, because the range was -1 to +1, and 0's right in the middle. Okay, and so we'll take the size height. Center point, we'll take the min there. I still don't understand why this one's dividing by 2. Okay. But this formula is force a minimum Y offset. So that was that buffer at the top for the radius, the piece of pi, and then take your maximum range minus your minimum and some percent of that. So it attempts to get us the bulk of the thing. And I think in our view, you can see it does. All right. But this means in our test, we did size 100 by 200. So 100's the minimum width. Minimum width is 100 or 200. So it's 100 divided by 2 is 50. And then the percent we said was 0.5. The height is, half of the height is 100. The Y offset is center Y, okay, was 100, minus the radius is 100 minus 50 is 50. So it should be 50 plus something. Percent is half, so it should be 50 plus max minus min minus height minus 50. Yeah. Minus height is minus 200. Minus 200 minus 50 is minus 150. Okay, so that's minus 75 plus min offset gives us minus 25. I think that's the answer we were getting. I think most of these, yeah, this was minus 25. Okay, and this one is doing repeats. It maps to the mid X. Well, it doesn't. Maybe, how can we say what this does? It's like negative middle of radius. Okay. And this even with repeats, yes, that's true. So the repeats shouldn't matter. Why is max Y offset the same as negative center Y? Is it? Yes. Yeah, that's the one I'm not. This is part of this is like the two things going on. One is we got 0 at the top and maximum Y, not max Y offset, but max Y at the bottom. That's one thing. But then the other is, because of that, when we do the offsets, we I think because we're offsetting the image, we're using the negation of it. Yeah, I think some of this is about the negation. Okay, so if the max y offset, this name maybe a problem too, but the minimum y offset. Okay, so center y is 100 because it's 200 high, minus 50 because that's the radius. Okay, and so the min y offset, the pi should never. Sorry, the bottom of the pi should never go above that min y offset. Okay, so that's the highest pi we allow. That seems okay to me. Now the maximum y offset, why that isn't size.height, right? I mean, well, max is confusing too. How is this? It's negative because max y offset is negative. Okay. Yeah, I think the calculations flip, but we've had to flip it so many times. I mentioned before, James Blinn was the guy who did all the computer graphics for the planet flybys with the rovers and explorers and whatnot. And he said, when you're doing all these multiplies, you have to be, the way to do this is you just be very careful to keep track of when are you flipping dimensions and so on like that. And then, if you're super careful at the end, you'll run it's backwards and you throw in one more minus one, one more times minus one to make it all work out. That's kind of how I feel with this stuff, because the direction is negative. If you're starting at the center and you want to go to the top, it's negative. All right. Now you're moving the picture up. Okay, so the picture position needs to get more negative. Like, ugh. Can I use center y plus min y offset? Center y plus min y offset. Here or So max y offset, that's so negative. And minus size.height is bigger than center minus radius, because center is plus size height over height, or over 2. You would think the max y offset, I would have thought it would be size.height. Okay, so it's always start with the minimum y offset. So start with 1/2. Oh no, start with the pi at the top of the screen. Your minimum y, which is like negative something, should be that. I think I'm saying it backwards then. If I'm trying to talk about the offset, well, it's not half the height, it's half the width or height, right? So it's that radius. Gosh, I think I want to negate some things and get this thing back into positive land at the end or something. I mean, okay, I need a picture. Half height, okay. What's maybe just here. Okay, So let's get a blob. All right. And then text. This is half the height. Okay. And then let's say the radius is half of this because it's the short side. Okay. So let's call this lowest point of pi. And not to be confused with pi, the numerical constant. All right. So that's that. Okay. And then max Y offset. So what I find weird, let's see if I can approximate a piece of pie. Let's flip vertically and paint it red. Okay. So I'll stretch this to half. And then that is half as well. Well, no, it's not that kind of shape. Let's get one of these. Okay, this is a little closer. So, can I drag it this way? Good. All right, and then this thing's radius should be equal to that. All right, so let's rotate it. 90. Okay. So if the radius is half, that should line up to the center. Okay. And then let's rotate it back. Okay. So if you're doing this, the highest the pi can be, okay, let's say this is if it's 200 vertically, right? So this is 50 because the vertical on the triangle is half the width because that's the short side. Okay, half the height is 100. Okay, so that's radius is the height of the pi, center is the center vertically, min y offset center minus radius. I don't know, the math is killing me here. Yeah, so take the center minus the radius. Does that make sense? The center minus the radius. Does that make sense? I mean, I think the the lowest y should be, if it's 0, then the triangle's up here. I'm gonna make another triangle to move around. Okay, if it's 0, the triangle's up here, the green triangle, that's no good. It has to be really the radius, I think. I think min y offset should be the radius. Now, I want to be careful how I change this. I think this should be the radius. Okay, because that the radius is that, which is half the height, and if it ever goes lower than the radius, then the well, No, if the tip ever goes lower than the radius. Maybe I'm being hasty here. Okay, if I take center minus the radius. Okay, let me I'm going to pretend these are right, but I'm going to adjust to make sure it is. Okay, so this guy, angle is 90. I should just type 90. Okay, and his size should be half. Okay. And that should definitely be less than half. Okay. So let's rotate this back to 0. Duplicate it. And change the color. Okay. So that's my minimum. Okay. So if the... It's like I so lost, sorry. There might be more image above the shape. Yeah, so what's the position we're putting, though, is... I think one of the things that's confusing to me is the offset is slide the image up from its center. And sliding it up makes it more negative. So that's why we're getting negative numbers for things, negative numbers for the offset there. But it's the image. I keep thinking I'm moving the pie, but we're moving the image. So I gotta make sure that's the way things go. So what's the maximum you would move the image up? I mean, I think the maximum you would move it up is this is the size minus the radius, the height minus the radius. Right, because if you moved it up any more, you're in the white space zone. So the maximum y should be height minus radius. Okay, let's make another version of this. Let max y is, well, let's just call it max y. Think of it that way. Max y is height minus radius. Okay, so if you offset, now are you offsetting from the center? Maybe that's the piece that's getting me. Okay, I think that's where the half is coming from. So if you start at the center, that's 0, 0. How much can you slide up? Well, it's half the height minus the radius. Okay, so I think that's max y offset. Okay, should be half the height minus the radius. Is that true? Okay, I'm going to comment these out for a minute. Okay, half the height. No. All right, so wait. This is an offset of 0. How much can you raise it? Well, it depends. I guess the most you could do is you want to slide this point to here is half the height minus the radius. Okay, so that's the most positive And that's an offset of minus that. Oh, golly. I'll tell you what. Let's take a brief break. And we'll come back and get this math right. It seems like it should be so easy, and yet I'm just not clicking it in. So for what it's worth, 3 or 4 minutes, we'll come back, we'll get this math under test, and then move on. All right, welcome back. Let's see, the pi point's at the center. Yes, max y should be half the height plus the difference of half the height minus the radius. I think that's what I think too. If I want to distinguish max y and max and the offset that corresponds to it. They're negations of each other in some sense. So that's, I guess the question should be, okay, so here's the starting point, wherever the center is there. We want to be able to go pretty much up to the top with the top edge and up to the bottom with the point of the triangle. It's really a arc kind of thing, but just to draw it easy. All right. The max y well, in a sense, yeah, the max y is the height, right? That's sort of a true thing. The max y offset, so the most you should be able to move this is half the height. Is that what we're saying? All right, let's pull out a constant for that thing too, just because is size dot height over 2. Okay, because I think that's easy to us. So the maximum, well, to get here, the most we can move is negative half height. Okay, so the maximum, I don't know, right? That one has nothing to do with the radius. The maximum, I call it maximum slide up. Max slide up is size dot his half height. Okay, so if you start with the point in the center, you can slide this minus half height. It's really minus because the way this thing offsets. Okay, extra space equals size minus rate. Okay, and then the max slide down, I think that's, okay, we're starting at the center, well, wherever that is. These are hurting us more than helping us. Okay. Okay, so starting at the center, the maximum we can slide down, well, is half height minus the radius. Okay, because really it's from there to there, so it's half height minus the radius. Minus radius. Okay. Okay, and then when somebody gives us the percent, we're going to take, okay, this I'm taking out. Okay, if we take, I don't know, I'm not sure who gets to subtract who. I mean, I got something that's in the range minus 100 to plus 25, say. So the range should be, usually it's max minus min, right? So I think it's slide down is the big one. Okay, so take max slide down minus max slide up. Okay, that should give me the range that's legitimate. And then I want that times a percent. Does that make sense? Is that all it is? Okay, let's try this for a moment. Okay, I'm gonna run this. Slide down is the extra space. Yeah, that's the space at the top, because we can slide down that much before we hit the top of the triangle or the pie. Okay. Yet another thing starts up. Okay. I did reboot the simulator at some point, but this is the size I set it to draw it in my over my Xcode. Okay, but he's starting up. Okay, already it looks bad. Yeah, we're back to this problem. Okay. And what we did here was the min-y offset. Is that... I think we're adding that back in, and is that half height or half height minus radius? I don't... And it's probably better to see it here. Yeah, we're already in trouble, huh? Let me get here. Okay, so you can see why it's blank half the time. Okay, so that is too positive, right? Oh, no, it's too negative. The slide down. I'm not sure if I'm in the positive. Yeah, is min-y offset the 0 position? Oh, it doesn't seem like it should be. Okay, I can go back to my picture. The maximum I can slide up, I think I switched signs somewhere. The maximum I can slide up is half the height. The maximum I can slide down is half height minus radius. Okay, is that what I said? Half height minus radius. Okay, but yeah, so I've got these. One's a positive, one's a negative. The slides up should be negative. And the slide down should be positive. So if it's 25 down versus 100 negative, so the difference then is 125. Okay, so Well, I guess I'm overthinking. We should put min y offset and then argue why it's right or wrong. All right, we'll run that. Oops. Well, I think I changed the name on me. Half height minus radius. Oh no. That's also max slide down. That doesn't seem right. Okay, what's the problem? So if I take it times a percent, 125, the difference of those two is 125 times a percent. I have to slide it back somewhere, right? So 125 times half is 62 and a half. So I really do need to slide it back. I don't know. Is it max slide down? Half the height minus the radius? I feel like it's either... Okay, that's clearly too much. Guess I was wondering if it was this. Just slide it back towards the y-axis. Okay. Well, that's promising, at least plausible. Okay, we're in range. We're way out of range. All right. I'm going to say it should either be half the height or the height. Okay, yeah, I think what you're saying is zero is when oh man. Okay. I guess the question I have is this looking possible, reasonable in the distance it goes? And we're starting off 1 pi above. Okay. Okay, so I added that piece of pi and it looked like it got off by. Okay. Height, distance. Let me start max side down. Total distance you can move the image is height minus radius. Okay. It's height minus radius. Is that what you said? Yeah. Okay. Because this minus that is half height minus radius minus half height is plus half height. So that's whole height minus radius. Yes. Okay. So by that, I want to take size dot height minus the radius. Okay. And that is times the percent. And then I got to get it slid down to the right place. Okay, so if I do that, it's too far. Okay, so if I do that, it's too far. Okay. Because these values are all, I don't know, I think it's like minus half height. This is really... Okay, if I slide up half and down a little, and then somebody says, I want to go somewhere between those, I guess up half to down a middle. Well, hey, now that looks all right. Let's see how the experiment shows it. Yep. Yep. And then over to the edge. I guess we're not looking at x coordinates, but all right. I don't feel good about how I got there. But, well, I don't know. Maybe I don't feel so bad. This max slide up, max slide down, I think that was right. And then the percentage of them is right, but then we have to offset it because that sort of treats gives you something in the range 0 to the maximum of the difference there, which we said was height minus radius. So if you take away the radius from the bottom, we're just trying to find how far down the image do we go so we have room to put the radius, either the pi at the bottom. And then, but we don't want that limited to that. So we got to shift it by, which apparently is half height. All right, because it seems good here. Let's make sure I'm... Okay, doesn't quite touch the top, doesn't quite touch... Well, maybe it just does touch. I can't do precision enough. All right. That seems good. This looked right, down to being similar stuff we've seen before. So it's tomatoes, more tomatoes. Yeah, that's a nice... Okay. Well, that is us convincing ourselves we have the right thing going on, which... I don't know. All right, we got half height, we got radius. Radius gets used down here, so let's move this down. Percent. I almost think this would be better inlined. Maybe not. Let's put this inside here, and then we can use half height here. Okay. We get the half height, we get the percent. I may pull this up and this down. Okay. So we kind of compute the percent. We then worry about the dimensions around it and then get the percent in and adjust. Okay, cool. Yeah, thank you on the math. Okay, so let's go back to our tests. 0 should be nothing, right? Angle.0 is negative middle of radius. Okay, so if the sign is 0, oh, that's really half, right? So percent is half. The half height is 100. The radius is 50, half the width, because that's smaller than the height. Okay. 150. So height minus this is 50 times a half is 25 minus half height is minus 100 is minus 75. Now what did we get for an answer here? Minus 25. Wait a minute. I'm gonna stop the run. We changed it. We haven't run tests since we changed it. Okay, but I'm predicting minus 75. You still have the radius versus half height. You can add or subtract to half height. Radius versus half height. Okay, so minus 75 was my answer, and minus 25. They got 25. Okay. All right, so self-irradiance of 0, sine of 0 is 0, gives us 1/2. Okay, so you still have the radius versus half height. You can add or subtract. Radius. Okay, so 1/2. Half height is 100. Radius is 50 versus 100 is 50. Height minus radius is 50 times 1/2 is 25 minus 100 is minus 75. Sorry, I'm not quite, but you still have the radius versus half height. You can add or subtract to the half height. I don't know. We don't have a lot of extra space vertically, at least in the experiment view. Why this is not minus 75, I am puzzled. Oh, because I didn't clear it. I'm going to clear. Okay, and run. I don't see how negative 75 is right either. Now this is saying we got minus 25. Even with repeats, right? These two should be the same. Okay, it is. All right. Why are you not what I want? Okay. Run this test. Okay, percent is 1/2. Half height should be 100. Whoop. What are you doing? I don't think it's running my test, is it? No, it's running main. Why? Did they change the way debugging works? Put a break here. Whoops. Not where I wanted it. Here. Oh, I'm running all these tests. Yeah, okay. Sorry. Well, no. Wait a minute. I set a breakpoint there, and I run this test. Okay, that's better. All right, well, let's just put the breakpoint here again. Okay, percent is 1/2. That sounds plausible. Half height is 100. Radius should be 50. Okay. Size.height, is 200. Is that, yeah, height is 200 minus the radius of 50 is 150, not 50. Okay. 150 times half is 75, minus 100 is minus 25. Okay, that is what we should expect. This one should be the same because it doesn't matter with repeats. It's n times the size. 100 times, times this, the sine of 100x is the same as sine of x. So sine of 100 times 0 is the same as sine of 0. So it should get the same result. Okay. Now, negative middle of radius. Okay, that is even the right answer. Yeah, okay. We'll take out the brakes when we get to them. All right. Next test. Okay, pi. So pi in a sine wave, zero starts on one side. You go up and down halfway through is pi, you're back to 0, and then all the way around again is back to 0 again. So if you are at pi, you should also be at negative middle of radius, because it should be the same effective sine value. Okay, to middle of radius should be minus 25. Negative pi, that's sort of like starting from the right, and again, that's got to be the same value. They're all coming up to the 0 points of the sine curve. Okay, now half pi maps to max x. That's not really that, it's really half height. No, it's really quarter height. 100. Half a pi is halfway around, is the maximum value is 1, so we should get our 100%. Is that right? 100%. Is it auto running my tests? Something updated. That'd be new. All right. So half pi radians pi over 2. Okay, so half pi should take us to 90 degrees. The sine is maximum there is 1. So we should get 125. I mean, we should get the height of things. I don't know if I believe this answer of 50. Okay. Negative half pi should map the other way around. Minus 100. Okay, so that's the... Oh, so 50 would be... 50... Okay, it's the quarter height is not really interesting. I think it's mapping to the radius. Let's see. So I think one corresponds to the maximum moving down, which isn't as visible in what we have now. But that's half height minus radius or something. Half height is 100 minus radius 50 is 50. Okay. I'm going to say half height less minus radius. Okay. All right. Negative pi maps to the minimum, which should be the minimum. It's not minimum x. It's really the minimum, the maximum. It's where we slide up half the height. Okay, so this is negative half height, which should be minus 100. Okay, and the repeat should work. Let me run this. All right, that's a good place to be. So that's odd. I think it's a leftover message. Let's try again. Okay, let's clear things. Yeah, this is... I don't know, there's some bugginess in Xcode. More than usual. I mean, I'm happy to see all the iOS 17 stuff for sure, but okay. This is good. Let's check it in. Okay. Fix to Y. And tests to match. I'm not sure we changed anything or not. It was too big of a jump. So I don't know. I don't know how to interpret that. I'm not too worried about it. I guess in the bottom line, we got back to a stable place, and I'll just run that one more time. Okay. Okay, so I want to see our circle is good with no bends, no white space. Okay, and that looks great. I'm totally happy with that. Now this, you go up to the top, down to the bottom. I guess I can see it better if I do that. To the top, and it looks like we're just touching the space we're given, but with our padding, we don't worry about running off the edge per se. I'm not quite sure how to. Maybe 20 pixels is less than I am thinking it is, or something. But at any rate, I think we're at a good place on this. Okay, so let's get to do. Should we move the pie? I think we're not going to do that. How do we rotate and scale picture to start right? Well, okay. I don't know if I want to worry about that one too much. We've got our original picture here somewhere. Yeah, here we go. Tomatoes are on the top, blues on the left, corn's on the right. We flipped something for our experimental view, but I think what we're seeing in the real one, I don't know. We can't quite tell from this. Yeah, I don't think you can tell what's where. I suspect the image may be flipped or something, though, if you, we're able to tell. Okay. But I'm okay with the stretched view that we have. Okay, so this takes our landscape picture and squashes it horizontally. I don't know. We tried a little... we might use slightly less of the image in the Y direction. I don't know. Is that true? I mean, we're that looks very close to the top, and that looks very close to the bottom. It might... Yeah, there may be a couple pixels difference or something. But at any rate, I'm okay with this stretched weird image because you don't... you're not really able to make out the real thing anyway. And I don't want to worry about if you didn't give me something. Now, I did try and rotate the image to fit landscape or regular portrait mode rather. But the once you've rotated it, it's resizable, doesn't know what to do because it doesn't work for views. It only works for images. I don't know. Somewhere, let's see. I saved a couple links, so maybe one of these will give us a clue. Okay, there's inset. I don't care about that anymore. Page requires JavaScript. That sounds like the one. Yeah, fitting images. Okay. I mean, they definitely talk about you can slam it in just like it is. Okay. You can resizable, which is what we did. Cap insets. I wonder what those are. Edge insets. Portion of the image not to resize. Okay, we're not doing that. Okay, so let's see the possibilities. So you just take the whole image and don't resize anything. It's way too big. This one we forced it to a fit mode, so it's resizable and it shrinks and it's got leftover stuff. Okay. You can clip a content mode fill, so resizable shrinks it down. But then, to the dimension that's the biggest, I guess. And then there's other stuff that doesn't get in there because it's clipped. Okay. Oh, what's the difference here? Okay. Oh, so you've extended the image beyond the bounds of the screen. If you just want to make it restricted to that, you clip it. Okay. Interpolation flags we're not going to worry about. You can tile. It looks like it just repeats how much it has room for, so that's not really what we want. So I don't think there's any. I don't see anything that does what I want. So I don't think I'm going to worry about that. Rotating in some circumstance. If I could rotate and then call resizable, I would. Because I'm happy enough with that. If it gets to the closest dimension, portrait or landscape, and then stretches out some amount from there, doesn't matter really. And I'm not too worried about the like we're only taking one bit of the image. I mean, we're sort of stretching the original image potentially. So, each pixel here is representing more than a pixel in our original image. I just can't think it's a real issue. When you see the level of detail and granularity in this, I don't feel like I'm missing anything pixel-wise. It just feels rich enough that if it's messed up from that. I mean, maybe these tomatoes look a little more squashed than they are in real life. These limes, limes are egg-shaped. These were kind of egg-shaped tomatoes. There's a little stretching going on there maybe, but I think we're good. All right, so rotate and scale, I'm not going to worry about. The tiling ID, I like it. But I think regardless, we would have to, what we did was make sure we can keep ourselves in the proper bounds for whatever we're doing. And if we can do that for the whole image, if we could do it for the tiled center image, we could do it for the whole image just as well. You might be able to get a little lazier. I guess you could, if you crossed over the tiled images, you wouldn't have white space showing. That's the good thing there. So, yeah, that would have prevented that problem, which is okay. That's definitely not an idea I'm going to forget, because I think it's definitely got some legs for stuff like this. Okay, so let's deal with these. Tab icon size. Oh, well, that's different. Okay, that's a totally different thing we're back to. All right. I think that's right. I think the kaleidoscope itself, for the static image we have, is what I want. We did want to make these things bigger, so let's try, let's switch gears and do that. I'm going to close Angle+toXY. I'm going to close a bunch of stuff. Content view. Okay, experiment view. All right. The challenge we have is that these photos don't, they just look little tiny icons, and we would like them bigger. I'm not sure. I think they look more round in the original picture than they did in this bit of stuff, wherever that in these, they look a little more oval or egg shaped to me. Whereas they looked a lot more round in this picture. So that's why I'm saying it's a little squashed. I don't think it's a ton. I mean, it's like maybe 25% or something. Okay. So if we like these images bigger, well, we're just passing in the image name here, so there's no sizing you can do. But there is another variant of label. Title icon, title system image. Yeah, so I think what we could do is like label photos and then put the image in here, which is image system name photo. And let's see if our preview actually works here. Oh, this is not what you can do. Okay. Let's find label in here. Okay, that's the one we've done. Label style title. I know we don't care about that. Icon. Maybe that's the version I want. Well, what we tried, okay, wait, label photo icon. Oh, they actually did icon : okay. Is that concat Barrea type string to expected label type style configuration? Oh, that's got to be a text. Okay. So I don't know the effect of putting two labels in one tab item. Okay. So let's comment out this one, and that should update. Okay, and now we're going to try and say dot font dot title, and it's not any bigger. I mean, is that just the way it should be? Well, I'm going to take the easy one then and not worry about the size. Okay. Let's see. So to do, all right. Oh, I guess I should add an item here for what we did. Modify to X and to Y offset to make sure they put pi inside the view. Update tests. Okay, that's true what we did. Icon size, I'm going to let it go. All right, select a photo. Okay, this is not anything I've ever done on an iPhone app, I don't think. There must be a way. Let's try Swift UI. There we go. No, that's not Swift UI. No. UI image. PhotosPicker. What's that? From the photo library. Okay, I think that's what we want. Yeah, image from the user media library. I don't really know the difference, but we want the PhotosPicker view. Okay. Picker.delegate equals self. That sounds like the old way. Present. This may not be possible with SwiftUI. Choosing assets from the photo library. Yeah. For UI kit. Okay. That doesn't seem to match PhotosPicker for UI kit. Okay. And app kit. Yeah, so that's not SwiftUI. Let's see if I can search a little more. Yeah, I think this may be what we're doing is this UI thing. Okay. Yeah. Well, that all looks okay. Well, this is the one I think is probably explaining things to us as well as anything. So what I think is going on is there's no SwiftUI. Oh wait, import photos UI and use PhotosPicker. Oh, okay. Yeah, thanks. Oh, good. Oh, that's much better. Yeah, because we'd have to write another 50 lines to kind of hook up the UI kit to SwiftUI. All right, so import photos UI. All right, now I guess back. Whoa, did I lose? There. All right. I don't know. We're doing so much of this app without testing, and I just don't have a good way to test the photo picker per se. Okay, but let's try it. Okay, so I think what we want to say is if you hit select, I think this is really like we should be showing a separate sheet. Well, I think the PhotosPicker name, they're probably using SwiftUI. I got the good name. PH PhotoPicker, right? That's the UI kit name. So Yeah, we'll take it. All right. So I think this button should, we need to show an extra view, and normally you just set a flag and then show the view when the flag is set. Okay. But let's just do it from a manual way for now. Photos UI. Okay. And then this button, I'm going to let it just take over the screen weird, even though that's not quite what we want. Selected items. Okay, we need some state. Good. I really only want to select one item, though. That's kind of funny. Okay. Oops. And then down here, now that's an action. Well, this whole thing is just kind of handy, actually. Selected item, matching any image. Max selection count. Okay, that's good. Let's pull this in. We'll want to pull this into a separate file, but I think this is kind of what you got. Matching images, and then we need that other flag. Was it max selection count? This does something matching. That does matching. Okay. One and that. And we'll okay. And where can we put this? I'm going to put it there for the moment. We're kind of experimenting with it as much as anything. All right, so instead of camera item, I'm going to put this view. Okay. Let's run. Well, I won't have demo there, that's for sure. Okay, so camera, select multiple photos. Well, I'm going to change that text. Okay, brings up some menu. Library shown here, Kaleidoscope can only access things you select. Okay, and this is just a default thing in their simulator. I'm trying to see which one will give a better. I don't know. That's probably too colorful. Okay, but that did something. Select a photo. Well, shoot, that almost sounds like I can do that instead of the button then, doesn't it? Okay, so let's just do photo selector. This used to say text camera. Okay, instead of button, we'll do selector. Okay. And then that thing sets, well, I guess that's probably okay. It's just going to have one in it. Yeah. Okay. Seen those images before. All right. So I think this will just put the button there that says select a photo. I'm not worrying too much about styling on this yet, but like I think this needs to be maybe on the left or up a little bit. But it does pop open something. I can select it, and that's fine. Now, what I get is a photo picker item. Do I get an action I can do? I guess on change of photos selected items, I gotta do something. Right, this is image demo. Now, how do we get... we need to get from a selected photo item. Okay. Photo picker item. Photos picker. Well, it does lots of stuff. I'll give him that. Photos picker item. Okay. Represents one thing. They're placeholders. Okay. Conform to transferable. Load transferable. Bringing photos picker to switch UI app. Okay, there's the photos picker. All right. Okay. Load an image. Did they just do a single? No. The sample contains an observed object that contains the selection. Selection only contains a placeholder object. Photos picker item adopts transferable. Well, my. Oh, sorry, did we get an image out of this? Image selection. It's photo picker item. It's progress. Image state equals success profile image.image. Yeah, I mean that's definitely a good question. So how do you tell you picked an image? I don't think you know, other than, I mean, this gets something in it. I mean, I think I can put it on changed and detect it maybe. Oops, on change of photo, what do we call them? Selected items. Okay, then we will do something. Value in. Oops. Print selected items.count. Okay. Yeah, maybe that state change stuff is the way to. With a 2 or 0 action closure instead. Deprecated. Is on change of initial. Well, that's weird. On change of value. initial is already set, and then I have this. So why do I need change of selected items? Okay, well, I'm not going to worry about that just yet. I'm going to change this to selected photo. Okay, and then in here, what do I have to have a selected items? Was that? No. Picker. It seems like I can just use the one value. Image selection. PhotosPicker. Selection. PhotosPicker item question mark. Okay, let's use that one. Why didn't you rename? Okay, so that starts nil. Binding of PhotosPicker. I got the wrong constructor. Selection binding PhotosPicker item question mark matching. Oh, I don't need the count anymore. Okay, and what's your problem down here? On change of selected photo, print selected photo. Let's just print it and see whatever it gives us. Okay. Yeah. Okay, select a photo. Take that one. Nothing printed. I don't know. I'm doing it. Okay, it's date, selected photo. Oh, I did this wrong. Did I just mess up something? Oh, I've got it twice. Okay, this is the one we want. And this is going to be a binding. Selected photo. Doesn't get a $sign? Oh. Okay. Yeah, I'll live with that. There we go. All right. Photo selection changed. We got something back. Whatever. It's got a photo ID. It says it's got an image type to it, so I'm good. All right. Well, that's a happy place to stop. I don't know why it didn't print before, but maybe, because I was I was printing out the value that never got set because it never passed it anywhere. So now we pass it. All right. Well, I'm happy with today anyway. We got the issue of the white space totally knocked out, and our circle is consistent now, so that is good. We got that thing back under test, which is really good, and we made a decent start on the photo picker. So I think tomorrow we'll focus on the photo picker, and given what I'm seeing, it doesn't look like we're too far away from making an image. We'll have to figure out how to attach it, but I think that could be done. All right, so thanks for joining today. Thanks for the people on the raid, if any of them are still here. And have a good evening. Tomorrow, 2 to 4:30 Eastern Time and 6 to 8:30 p.m. UTC. Let's see. Today's Wednesday. Tomorrow's Thursday is our last day this week. I'm going to be gone the next couple of weeks. So I'll update my schedule wherever that is somewhere and reflect that. So tomorrow I hope we can finish the photo selection, and then after I'm back, maybe we'll tackle some of these other the camera itself or the 3D kit stuff. All right. Thanks again. Take care. Bye-bye.